housing, it's dramatically higher there, even if they have to travel a longer distance to get to their employment. And it's because of that amenity, namely, what is a local public good, namely the schooling that can be offered for education of their children. And with regard to, this is a sidebar, right? But with regard to Berkeley and other communities like Berkeley, when the public schools begin to deteriorate, what happens? The self-selection process goes on. And they deteriorate even faster. Why? Because the parents who really care and can afford to take their children out of the schools and send them to private schools. And it's like a vicious circle. In contrast, in Orinda, it goes the other way. Because the public schools are so good and the parents care so much about it and are so actively engaged, those schools get better and better. But having said all that, that's what the hedonic pricing methodology is all about, is to look at all the factors that drive the value of some asset or some good, or for that matter, the wages that are paid for laborers. Because the wages that are paid are composed of lots of different attributes with regard to your activities. Okay? When I was in Washington, D.C., for the State Department, different employees of the State Department and U.S. embassies throughout the world, you say, gee whiz, if somebody is serving as chief of staff in a particular embassy, are they paid the same price in each country? Why not? Why not? Why wouldn't they be paid the same price? Yes. Cost of living is different, yes. But there is another major difference. So let me give you a hypothetical example. Suppose you can be the chief of staff of the U.S. embassy in Iraq versus being the chief of staff of the embassy in Australia. Are you going to demand more compensation for being the chief of staff in Iraq? Yes, exactly. And that risk, that incremental risk, is reflected in your wage compensation. So now, if you know what the incremental wage compensation is, what economists and statisticians have done is use that information to determine, quote, the statistical value of life. By the way, but if I'm going to go out and evaluate, suppose there's a huge degradation in air quality. And with that degradation in air quality comes a higher probability of the risk of acquiring cancer, for example. How am I going to go about valuing to society whether I should incur the cost of abating that degradation of air quality? There's a cost of doing so, but on the benefit side of the equation is how much do you reduce the chances of health hazards or the risk of cancer or whatever. So this little example about the statistical value of life becomes meaningful if you're going to get a fix on the benefit and cost calculations with regard to whether I should incur the use of scarce resource to abate the degradation of some particular resource. And air quality is a classic example. Okay, hedonics. Two houses, we've already covered this in our simple example. By the way, in every major city in the United States, there has been litigation somewhere along the line because of some landfill, because of some weather event, has overflowed, and that landfill has dispersed waste around the residential properties located near the landfill. So if you're sitting there and you're thinking about, I'm going to buy a house in Houston, why you would ever want to do that is beyond me. But if you were thinking about locating in Houston because you want to go to work for one of the major energy companies, whatever. But anyway, you're evaluating this, and there's a number of landfills within the city. If you buy a property near the landfill, you'll pay considerably less than buying a property that's 10 miles away from the landfill. Why? Because the risk that that landfill may be mismanaged or there's some abnormal weather event and it ends up with your property being contaminated and or the water, the tap water at your residence being unavailable for use. Okay. So there's been a number of studies, and it turns out that the value of housing as you move further and further away from the landfill goes up. There's like a price gradient moving away from some source of contamination. All right. Now, the first known example in hedonics was somebody came along and tried to estimate the price of cucumbers, and they realized that cucumbers are not homogeneous, right? They come in different sizes, different shapes, different quality. So what they did is said, okay, let's look at the prices and try to take that price and decompose it across the attributes of cucumbers. You can do the same thing with regard to residential housing or wages for a particular employee. So what you're trying to do at the end of the day is simply explain the price decomposition across the attributes or characteristics of the good that is being exchanged. As I indicated, the most frequent use is to look at housing, and moreover, it's a very rich data set. Every county in the United States collects transaction database about the most recent transaction that takes place, and they have a full description of the property because you need that for appraisals, and you need that for determining property taxes, so this is all readily available information. And once again, regress, coming back to statistical analysis, you regress the prices across these various characteristics, and here's one of the examples discussed in the reading for today, is to look at some environmental contamination that took place within a particular location, and they came along and estimated a regression equation in which you have here, for those of you who haven't been exposed to regression or statistics, all you're doing is trying to take the price associated with housing transactions near a particular natural resource. And you have the lot size, the distance to various forms of sources of employment. You have, in addition, the density in surrounding areas, the amenities with regard to wetlands, et cetera, et cetera. But in addition, they estimate what is the effect of environmental contamination, and that is the last variable that appears here. And that effect turns out to have a negative effect on property values because as the concentration, the fecal concentration measure, as it goes up, the value of housing goes down. So if I can remove that contamination, I'm going to get higher values of housing. Right? Okay, this is table 6.4 in your textbook reading for today that's explained there. Okay, the value of statistical life. Let me go through this very quickly. And the example I want to use, and this is the one in your textbook, you've got an employee that is considering two choices. Or she is offering her labor services, and she can either work in a grocery store, for example, and suppose the grocery store is in Orinda. By the way, I don't live in Orinda. I don't want you to infer that. I have a preference for Orinda because I don't. Okay, versus this person looking at going to work in a grocery store on 92nd Street in Oakland. Has anybody been there? If you haven't, don't go. In any event, it turns out that if you look at the actual data, and this is discussed in your textbook, what is the risk of death in one neighborhood versus another? And the safe neighborhood has only one chance in 10,000 of dying in a particular year. The dangerous neighborhood or the unsafe neighborhood has a much higher risk of death in each year. And you can take that basic data, and by the way, suppose the employee comes along and says, I'm not going to work in the bad neighborhood unless you give me another $1,000 a month. So there's a signal in that $1,000 a month. Right? And the signal is, how much do I value this incremental risk that I'm going to face? And for that incremental risk to be consistent with $1,000, it implies a value of life, my subjective value of my own life. Right? So in your simple textbook example, if this employee demands $1,000 more per year for the risky or unsafe neighborhood, and they accept this incremental risk, that's an incremental risk, because notice the difference between the two is 1 in 10,000, the other is 3 in 10,000. Right? And for that to be consistent, you can compute by taking the probability times the 5 million to get the 1,000, or to reverse engineer that, and the statistical life that's consistent with that $1,000 increment for a incremental risk of 2 in 10,000 versus the safe neighborhood as being just 1, that would be $5 million. And by the way, those of you who are interested in the statistical value of life, I'm the editor of the Annual Review of Resource Economics, and in the last volume 4, there is a wonderful article by Maureen Cropper on the statistical value of life and how it's used in terms of valuing environmental resources. It's probably something you should read when you're in graduate school, but many of you could assimilate this. It's fairly straightforward, and it's an interesting. Yes? If we were what? Yes. Yeah, certainly. Adam makes a good point. It's a loss causation. The presumption here is in the unsafe neighborhood, someone's going to shoot you. In the safe neighborhood, there's still a small chance you're going to get shot, but it's smaller. Right. Oh, no. The loss causation, when we talk about safe versus unsafe, we're inferring some external uncontrollable threat. Yes? Justin, right? Yeah. Speak up, Justin. Right. By the way, let's bring it closer to. Yeah. You can go on. If you take the simple example of joining a fraternity or a sorority, the risk goes up, right? Okay. Okay. The same hedonic. Now it's wages instead of prices of homes, but it's using the methodology to decompose a price or a wage across different characteristics. That's what hedonic methodologies do. Okay. Wages and risk. I've covered that. Let's turn. I've already stated this. That's what hedonic models do. They establish the relationship between a value of something and its characteristics and attributes. And that's true with regard to wages as well. And with respect to some degradation of a natural resource and how it impacts surrounding properties. Take the simple example that we were referring to earlier about crop production and the cattle raiser or the Coase theorem, right? Suppose the crop producer is located in the middle of nowhere with no cattle around. Okay? That crop production doesn't have to worry about any potential degradation of their vegetable production as a result of some movement of cattle onto their property. Right? So, as a result, the value of vegetable production located where it's not threatened by surrounding cattle should be higher, everything else constant, than than crop production or vegetable production being located close to cattle. And that's basically the point. It's no more complicated than that. Yes, Paul?
Let's say you have that farm of vegetables in the middle of nowhere, and there's a wild animal that's going through your farm and destroying everything. Do you have the right to kill those or eliminate those wild animals? Does the farmer have the right?
You're asking me a legal question. This is an economic course, right? But my answer is yes, you have the right to do so. Okay, so the hedonic methodology is a number, just estimating a relationship between price and all the characteristics and surrounding attributes that is available at a particular location. All right, let's briefly look at averting behavior. The basic idea is that people can mitigate the harm or contamination that has taken place to some natural resource. For example, when you go through the airport these days, in some parts of the world, people have masks on. That's what they're doing, right? They're averting the risk of environmental contamination. That's the reason for putting the mask on, I presume. Or better yet, the risk of contamination from surrounding people who have the flu or a cold or something along those lines. No, it's both. It's both in some parts of the world, yeah. Okay, but in any event, that's the averting behavior. The best example is when groundwater is the source for your tap water, and it's been contaminated by some chemical, and you go out and buy bottled water. In fact, it turns out that in many parts of the bay, there are different underground aquifers that are the source for drinking water. And whenever they've been contaminated, once the finger printing has taken place, and you find who the responsible party is, the first step on the part of the responsible party is to go out and make free bottled water available to all the residents that are accessing the drinking water from that aquifer. Right? But in addition, consumers can go out and avoid that sort of behavior. And what really happens, by the way, with regard to most consumers, they're just averting the risk, right? It turns out that in many parts of the country, the drinking water is actually superior to bottled water. But people still, the premium that you pay for bottled water? It's huge. Yeah, I know, but it's just because people are trying to avert risk when there is no risk there. They just feel more comfortable doing it. But nevertheless, the averting behavior, the classic example, is buying bottled water to avoid contamination of an environmental resource. The environmental resource is water, and it's a drinking water, most of which comes from one of two sources, either surface water or groundwater. The stuff, or the drinking water that comes from groundwater, there's all sorts of issues associated with chemical contamination of the groundwater sources. Adam? Yes, certainly. But look at, huh? For them, you mean? Oh, yeah, no. Look at all the new entrants talking about competitive structure. Look at all the new entrants in bottled water. If you go to the local grocery store, Andronico's or Safeway or any of them, the number of different items of bottled water expands every time I come back. Every week, there's a few additional brands that are there. And many people buy the brands because they like the shape of the bottle. I don't think there's this, well, I haven't done a serious study about whether it's distinguishable, but the fundamental point is that it is a real benefit to all those manufacturers of bottled water because it moves their demand curve everywhere to the right. Oh, no, but they have to get a source for water. And they have all these representations about this water is pristine, we'll run through all these rocks, and it's been steamed and cleaned, and whatever. But the take-home message here is that you can infer value in terms of reveal preference if you find, separate all the facts that we just discovered, but suppose you're at a particular site and the groundwater's been contaminated, it's a source for drinking water, and all the residents there are not drinking that water any longer, they're going out and buying bottled water. So the bottled water must be preferred to the drinking water. It's revealed. It's a revealed preference. And if their incremental cost of doing so is whatever, 75 cents a bottle, and they drink 20 bottles a month, and then I end up with $14, whatever the number is very quickly, $14 per month, that is the measure of the environmental damage, and also a measure of what the value would be, at least for that residence, of cleaning up that contaminated drinking water. And if I sum across all of them, I can end up with a very big number as being the benefits of remediating that groundwater. Okay? So that's the fundamental point about averting behavior. And here, your textbook say what? Okay. A real-life example, this is discussed in your textbook, is just illustrating a study that was done using averting behavior to estimate what the value is of that resource.